Good morning students. In this video, we will discuss about reflection of light from the plane mirrors. Right. So, first of all, we will discuss about the concept of reflection. In previous class, we already learned the first property of light, that is rectilinear propagation of light. That means light always travel in a straight line path according to the ray optics. Now, coming to the second property is reflection of light. So, this reflection takes place very important role, especially to see all the objects around us. If it is a opaque object or transparent object or translucent object, right? It is independent. Reflection is independent on the nature of the surface. From all the object, light should be reflected and reach to our eyes. So that is the phenomenon which is used to see all the objects around us. Right. So what is reflection? Reflection is nothing but a bouncing of light or return back of the light in the same medium is called as reflection of light. Okay. So depending upon the nature of the surface, because some surfaces are very smooth like board or polished surfaces or looking glass mirror. So all these are examples of plain surfaces, smooth surfaces. But some of the surfaces are very rough. For example, wall, ground, floor. These all are examples of rough surfaces. So depending upon the nature of the surface, reflection classified into two types. They are regular reflection and irregular reflection. Here, irregular reflection also call it as diffused reflection. Diffused. Right. So, what is regular reflection? How to define this? Let us consider a smooth surface. Let us consider a smooth surface. For example, mirror. Mirror means mirror is nothing but a piece of glass which is polished in any side, silverized or polished. Okay. For example, from the source of light, a parallel beam of light is falling on it. Parallel beam means each and every light ray is parallel to each other. So, parallel beam of light is falling on the smooth surface. After reflection, what happened? All the reflected light rays are as a parallel beam. Right. So this type of reflection is called as regular reflection. So in which in which path it will falling on the mirror, in the same as a parallel beam only it will reflect it. Right, in the opposite direction, in the same medium is called as regular reflection. So due to this regular reflection, in some times depending upon the nature of the surface, if it is very smooth, some glareness will be formed for our eyes. Glareness. That means some slightly blurriness depending upon the highly polished surfaces. So in which surfaces you can observe this regular reflection means from mirror, from highly polished surfaces, including oily surfaces, highly polished metal sheets. All these are examples of regular reflection surfaces. Right. So, in some more surfaces, for example, surface is very rough like ground or wall. Okay. So, what happened? How to form the how to travel all the reflected light rays means a parallel beam of light only falling on it. Here also parallel beam of light only falling on it. But after reflection, they are not travelled as a parallel beam. They are travelled in a different directions like this. Observe the reflected rays carefully. All those reflected light rays are not as a parallel beam. They are travelled in different directions. So such type of reflection is called as diffused, simply irregular reflection. So in which surfaces this irregular reflection happens means all rough surfaces, wall, bricks, including leaves, books. So these all are examples of substances from which irregular reflection will happen. Okay. So compared to these two reflections, which one is helpful for us in the sense irregular reflection only helpful for us. Because in this irregular reflection, light travelled in a vast region. ఎక్కువ దూరం travel చేస్తుంది. At the same time, it is very helpful to see all the objects which are far to us also. దూరంగా ఉన్న objects ని కూడా clear గా చూడగలం. So these two are types of reflection, regular and irregular reflection. Clear? So now coming to the terms related to reflection. Some terms will be very important. What are the terms related to reflection? For example, let us consider as plane mirror. Plane mirror. So just now I explained plane mirror has a polished surface. Other side is act as a reflecting surface. This is reflecting surface and it is polished surface. According to the rule, object should be placed always in front of the reflecting surface. Looking glass is the best example. Mirror means looking glass. So object should be placed in front of the reflecting surface only. So from the object, let us consider a single light ray which is falling on the mirror in the direction AO. In the direction AO. Here AO is called as incident ray. AO is called as incident ray. So incident ray means what ma? The light ray which is falling on the mirror at any point on the mirror is called as incident ray. So immediately what will happen from the mirror? Actually here mirror has some characteristics. Good mirror has some characteristics. What are those? Maximum light should be reflected from the mirror and reach to the person eye. Very less amount of light only absorbed by the mirror. Okay, and very less amount of light only transmitted by the mirror. So these all are the characteristics of a good mirror. Okay, so maximum light should be reflected. So it is reflected in the direction OB. Here OB is called as reflected ray. OB is called as reflected ray. AO incident ray, OB reflected ray. Okay, from which point the light is reflected? From which point light is reflected or at which point light is falling? At the point O, here light is falling. The point O is called as point of incidence. Point of incidence. The point is O. Okay, so let us consider a imaginary perpendicular line to the surface. A imaginary perpendicular line to the surface is called as normal. Normal. Observe that line ma. It is exactly perpendicular to the surface. Surface means for mirror. Perpendicular only. That is called as normal. Now next term is angle of incidence. Angle of incidence. So what is meant by angle of incidence? Here incident ray makes some angle with normal. Incident ray makes some angle with normal. That angle is called as angle of incidence. It is represented by angle I. Right. At the same time, here normal also makes some angle with reflected ray. Normal also makes some angle with reflected ray. So that angle is called as angle of reflection. Angle of reflection. It is represented by angle R, small r. Angle of reflection. Here one more point. Here incident ray not only makes some angle with normal. It also makes some angle with surface. Simply mirror. That angle is called as GI. Simply glancing angle of incidence. Glancing angle of incidence. Right. It is represented by G suffix I. Angle GI. At the same time, here reflected ray also makes some angle with mirror or surface. That is called as glancing angle of reflection. Glancing angle of reflection. Next term, glancing angle of reflection. It is represented by G suffix R, angle GR. Right. So these all are different terms related to the reflection. Okay. After that, we should learn about laws of reflection. Reflection has two laws. So from the diagram only, you can learn laws of reflection. So what is the first law of reflection? First law manaki em represent chestundamma? First law represents angle of incidence always equal to angle of reflection. Very important. So with what angle it will falling on the mirror, or with what angle incident ray and normal. What is the angle in between the incident ray and normal? The same angle is formed in between normal and reflected ray. That means if angle of incidence, let us consider 30 degrees. This is the angle in between normal and incident ray, 30 degrees. What is the angle in between normal and reflected ray? It is also equal to 30 degrees. Equal to 30 degrees. This is the first law of reflection. That is always conditioned. Next, what is second law of reflection? Second law em represent chestundi mani. Second law, observe the light rays carefully. Incident ray, reflected ray and normal. Right. What are they? Incident ray AO, reflected ray OB and normal ON. These three light rays are lies in the same plane. Okay, plane lo untai. Lies in the same plane. That is second law of reflection. These two are two laws of reflection. Okay. Right. Coming to the next term related to the plane mirror, angle of deviation. Very important concept. Angle of deviation. Deviation means in the presence of mirror, the incident ray deviated and it makes some angle with reflected ray. In the presence of mirror, it will happen. Just see this diagram. Okay, let us consider initially a piece of glass. It's not a mirror, amma. It is a piece of glass. So you know, piece of glass is a transparent material. So what happened from the, piece of glass? If the light ray is falling on it as the incident ray AO, some amount of light automatically reflected in the path OB. Right? But at the same time, from mirror, there is no transmission of light because mirror is completely opaque. Right. But here it is a piece of glass. Some amount of light is transmitted in the path of OC. Here OC is called as extended incident ray. Okay. In which situation it happens? Only in the presence of piece of glass only it will happen. For example, now instead of piece of glass, now you can replace the mirror. Now you can replace the mirror. Immediately what happened? This extended incident ray is deviated. Means it changes its direction anamata. Direction changes iskuntundi. Danni manam deviate avadam antam. It changes its direction and it makes some angle with this reflected ray. That means it simply moves towards the reflected ray anamata. It moves towards the reflected ray and makes some angle with that reflected ray. So that angle is called as here angle of deviation, angle D. Okay. With what angle it is deviated? Enta angle to deviate ayindi, you have to calculate. Right. So observe the figure carefully. It is a straight line. You know the angle in a straight line is 180 degrees. Right. Very important point here. Students, listen carefully and remember, here 180 degrees is called as pi radians. 180 degrees ni manam according to the angles chapter in mathematics also manam danni pi radians ani pilustam. 180 degrees is pi radians. Remember that. So here total angle is 180 degrees. That means you can write it as angle I plus angle R plus angle D. Total angles, 3 angles we have, equals to pi radians. Equal to 180 degrees kada? I wrote instead of 180 degrees, pi radians. You know, first law of reflection. Just now you learned. Angle of incidence is equal to angle of reflection. That means directly you can replace angle of incidence plus angle of incidence plus angle of deviation is equal to pi radians. Therefore, 2 into angle of incidence plus angle of deviation is equal to pi radians. You can calculate angle of deviation directly by pi radians minus 2i. So this is the formula to calculate angle of deviation only for one plane mirror. How many mirrors I took here? One mirror only, no? What is the formula? Angle of deviation is equal to pi radians minus 2i. In numerical problems, he will give the angle of incidence or angle of reflection. Both are same kada? Angle of incidence he may be given as 30 degrees for example. What is the angle of deviation in that situation? Angle of deviation is 180 minus 60. 2 into 30, 60, no? So 180 minus 60, 120 degrees is the angle of deviation. Right. So this is the way to calculate angle of deviation for single mirror. Now coming to the next concept is angle of deviation from two mirrors. Means if two mirrors are inclined with an angle theta. Two mirrors ni mana inclined chesam. So what you learnt here to understand the concept of deviation, initially what we have to do amma? Instead of mirrors, first of all we have to consider piece of glasses. Right. So from piece of glasses also some amount of light is reflected. Observe the figure carefully. Here incident ray is travelled in this direction and falling at the point A. So what happened from the point A? Some amount of light is reflected, is falling on the second piece of glass at B, and some amount of light is transmitted because that is piece of glass, no, transparent material. And from the second piece of glass also some amount of light is reflected and some amount of light is transmitted. Just same concept. Right. So what happened here? Observe the angles carefully. It is an incident ray. Let us consider a normal here. The angle is angle of incidence and this angle is angle of reflection. But from angle of incidence is equal to angle of reflection, directly you can replace angle of incidence plus angle of incidence. Right. Coming to the second mirror, again consider the normal also here. This is angle of incidence and it is angle of reflection, again both are same. Now one more point you should learn here, that is glancing angle. Glancing angle means what ma? Angle in between this one. Angle in between incident ray and mirror. And mirror. Mirror means here piece of glass. Right. So this is, let us consider as alpha. Alpha, Greek letter alpha. Okay, you know one more point. Glancing angle of incidence. Glancing angle of incidence is equal to glancing angle of reflection. E value 30 degrees ainappudu. Glancing angle of reflection also equal to 30 degrees. So that's why this is glancing angle of reflection, that is also equal to alpha. Similarly, here I considered glancing angle as beta, incidence, and reflection also equal to beta. Right. So you know one more one more law in mathematics. Vertically opposite angles are equal. So see this here alpha. It is a vertically opposite angle. Here it is a vertically opposite angle equal to alpha. It represents what ma? It represents angle in between piece of glass and extended incident ray. Vertically opposite angles are equal. Here also vertically opposite angles are equal. Right. Now here piece of glasses, piece of glasses are replaced by mirror strips. Mirror to replace cheyali. Immediately what happened? Here extended incident ray makes some angle with reflected ray. So that is called it as angle of deviation from the first mirror to alpha. Alpha plus alpha to alpha. Right. Again from the second mirror also similarly, extended incident ray makes some angle with reflected ray, that is beta plus beta 2 beta. So now we have to calculate total deviation. So total deviation how to calculate ma? D1 plus D2, that is simply after taking 2 as a common, 2 into alpha plus beta. Observe the figure carefully. Here you observed a small triangle. You know, total angle in a triangle is equal to 180 degrees or pi radians. That means alpha plus beta plus theta is equal to 180 degrees or pi radians. Okay, so from this you can calculate alpha plus beta is equal to pi radians minus theta. Okay, if it is multiplied by 2 in both the sides, 2 of alpha plus beta is equal to 2 into pi radians minus theta. Just now here you already proved 2 into alpha plus beta. 2 into alpha plus beta represent what amma? Total deviation. That means total deviation D is equal to, how to calculate? What is the formula? 2 into pi radians minus theta. What is the value of pi radians ma? Pi radians, angle of deviation is equal to 360 degrees minus 2 theta if it is multiplied by 2. A of B minus C, AB minus AC kada. So how to calculate angle of deviation for two mirrors ma? 360 degrees minus 2 theta or 2 of pi radians minus theta. So like this you can incline number of mirrors. If for example if you can incline 3 mirrors, how to calculate angle of deviation? Instead of 2, just you can replace 3. That means 3 of pi radians minus theta. So like that angle of deviation you can calculate by the formula n of 180 degrees minus theta. N represents what amma? N represent number of mirrors you took. Any mirrors తీసుకున్నాము. So this is the concept of angle of deviation. Right? Right. Now coming to the next concept, rotation of mirror. That means mirror is rotated by some angle theta from its initial position or from its actual position. Actually గా ఉన్న పొజిషన్ కన్నా theta angle ని మనం mirror ని rotate చేసాం. So in that situation what happened means, if the mirror is rotated by some angle theta means any angle you can replace, 10 degrees, 20 degrees, 30 degrees, any angle you can replace. In this situation, reflected ray may be affected. Reflected ray may be affected. In which situation it happens means, by two conditions it happens. In first condition what you learnt, for a fixed incident ray. Fixed incident ray means no change in the incident ray amma. Incident ray fixed ga unchestam. Mirror position only changes with the angle theta. Right. Observe the figure carefully. Before rotating the position is m dash. I repeat. Before turning the angle by the theta, the position is m dash. Okay. So from the first position, observe the figure carefully. From the first position, angle AON is normal amma. AO is incident ray. Okay. OB, listen carefully. OB is reflected ray and ON is normal. ON is normal. So from that figure, okay. So angle AON is equal to angle I. AON, angle of incidence, and angle NOB, angle of reflection, also equal to same angle of incidence from the first law. Now total angle I calculate. Angle AOB, మొత్తం angle ని calculate చేసాం. Angle AOB is equal to how much ma? 2 into angle of incidence. Let us consider equation 1. This is the value of total angle before rotating the mirror with a constant or a fixed incident ray. Now just change the position of just change the position of mirror from M dash to N dash, or sorry, PP dash. PP dash is the new position of the mirror. ఎంత angle ని make చేస్తోందమ్మా? This is the actual position of the mirror. This is just now I changed the position of mirror like this. Theta angle ni rotate chesam. Theta angle. Here I wrote theta. Theta angle ni rotate chesam. With a fixed incident ray. No change in the incident ray position. But because of change in position of the mirror, normal should be changes. What you learned in the concept of normal. Normal means always perpendicular to the surface. Ippudu perpendicular ga unnadi. But initial position is not perpendicular to the second position of mirror. That's why here it is the normal N dash. So how to affect? Enta effect ayindi normal. With what angle mirror is rotated, with the same angle normal is affected. That means theta. So this angle in between the two normals is theta. Theta. Right. Now you should calculate new angle of incidence. New angle of incidence. I repeat. Angle in between incident ray and new normal. Old normal machikoval. New normal. Already from here to here angle of incidence I. So therefore from the second position what happened ma? Angle AON dash. AON dash value is I plus theta. Angle I plus theta. Why I added theta here? Because theta angle I rotated. That's why theta I added here. For example, if it is rotated by 2 theta means what happened then? Angle I plus 2 theta will come anamata. Understood? Right. Now, according to the first law of refraction, what is the angle of incidence? The same angle is angle of reflection. Angle of reflection means what ma? Angle in between new normal and new reflected ray. New reflected ray, that means angle in between new normal and OC. OC, that means angle N dash OC. I repeat. N dash OC. The angle is again I plus theta. Both are equal kada according to first law. Now again we have to calculate total angle AOC. Angle AOC become angle I plus theta. Okay. Plus angle I plus theta. Down I wrote ma. Angle I plus theta plus angle I plus theta. Total. That is angle AOC is equal to how much ma? 2 into angle of incidence plus 2 theta. 2i plus 2 theta. Right. So this is the value, the total value when the mirror is rotated by 2 theta angle. What is our aim? If the mirror is rotated by theta angle, with what angle reflected ray will affects? Reflected ray enta effect avutundi. That means this area we have to calculate. In this area what is the angle we have to calculate? Enta angle effect ayindi. How to calculate ma? Easy. You can subtract initial value 2i. That means this value before rotating, what is the value nana? 2i. That value should be subtracted from the total value AOC. That means therefore angle AOC minus angle AOB. I repeat. Angle AOC minus angle AOB. If you can subtract those two values, you can get the value of theta. That means what is the value of, what is the angle of reflected ray? Substitute the values. AOC value how much ma? 2 into angle of incidence plus 2 theta minus, and AOB value is minus 2 into angle of incidence. Any possibility cancellation here? Yes. 2 pi plus 2 pi minus 2 pi will get cancelled. So what is the value here? Angle BOC. I repeat. Angle BOC represents what na? Angle in between old reflected ray and new reflected ray after rotating the mirror by the angle theta. Right. So what is the value? Answer is 2 theta simply. మిర్రర్ ని మనం theta degrees తో rotate చేసినప్పుడు reflected ray is affected by twice that of angle. Twice that of angle. For example, mirror is rotated by the angle 10 degrees. With what angle reflected ray is affected? Yes, reflected ray is affected by the twice of the angle 20 degrees. Right. So it is happens only, this is very important condition. In which situation it happens ma? 2 theta మనకి ఎప్పుడు వస్తుంది? When fixed incident ray, no change in the position of fixed incident ray. No change the position of incident ray. Mirror position only changes by the angle theta. Right. Coming to the next case, in rotation of mirror only. In before case, what you learnt amma? Mirror is rotated by an angle theta. No change in the position of incident ray. But now we have to change the position of incident ray. No change in the position of mirror. Observe the diagram carefully. Here also I took one mirror na, dash mirror I took. Okay. So here AO is incident ray falling on the mirror at the point O. From the point O it will reflected in the path of OB and ON is normal. So according to the concept, what we have to do amma? No change in the position of mirror, but incident ray rotates by an angle theta in any direction you can, in a clockwise direction or in a anti-clockwise direction. Right. For example, here I rotate the incident ray like this, in this direction. In this direction I will rotate. With what angle? By the angle theta. Theta angle to rotate chesam. So here theta is the angle in between new incident ray and old incident ray. Okay. A dash is the new incident ray. A dash O. Okay. According to the first law of reflection, what you learn? Both two angles are equal. Angle of incidence is equal to angle of reflection. Right. So here the total angle become angle I plus theta. The total angle in between incident ray, new incident ray and the normal, how much ma? Angle I plus theta. Automatically, with what angle the incident ray is rotate? With the same angle, what happened? Reflected ray also will rotate in the direction OB dash. Here OB dash represents what amma? New reflected ray. With the same angle it will affect. Reflected ray same angle tone affect avutundi. So that means here the angle is also equal to theta. The total angle means the total angle of deviation become how much nana? I plus theta or R plus theta. But in opposite direction, right? It is in this direction and it is in this direction. So this is the rotation of the effect of the reflected ray when fixed mirror and incident ray is rotated by an angle theta. Concepts related to the reflection from the plane mirrors. Right. In next video, we will learn about the properties of image formed by plane mirror. Okay. And height of the mirror, including periscope concept. Right, students? Thank you.